Welcome to the next major section, Chapter 7. We're doing Chapter 7.1, something called rational expressions. Now, a rational expression, what is that? Well, think back in your previous math courses. They must have mentioned something called rational numbers. And a rational number is basically just a fraction, a numerator and a denominator. A rational expression is a fraction that has variables somewhere in it. And so a very simple rational expression is this guy right over here, 24 over y. Now what they're asking you to do in this problem is they say, well, the problem, what is a fraction? A fraction is basically a division. Okay, 24, this means 24 divided by y. And you know you cannot divide by 0. So the problem is, what they're saying is find all the numbers for which the rational expression is undefined. Well, you know, y can represent any value you want except for what number? Well, you cannot plug in 0 for y. Okay? If you try to plug in 0 for y, then you're attempting to do 24 divided by 0, and yet it can't be happening. So for the answer to that problem is the number for which the rational expression is undefined is the number 0. Any other number it's defined. I can plug in any other number, I'll get a value. Okay? That's what they mean by defined, that you have a legitimate value. But 0, no. There you go. So what do you think this answer is? Now, don't say 0. I've been doing this course for a long time, and kids think, students think, oh, 0. 0 is not always the answer to everything. Okay, I can plug in 0 for z here. If I plugged in 0 for z, 2 divided by negative 6 would be negative 1/3. It's defined. The one number I cannot plug in there is 6. Because if I plugged in 6 for z, 6 minus 6 would be 0. 2 divided by 0, it can't be done. So for that problem, you get 6. So the whole idea behind rational expressions is that they might look pretty, and they might have variables, but only certain values can be plugged in. And the values that you can plug in have to be values that don't make the denominator 0. Okay? When you evaluate the denominator, that denominator cannot be 0. That's all that is. Okay, great. Nice work. Okay, now this you've seen before. I know you've done this in Algebra 1. This is a rational expression. The problem with this rational expression is it's too heavy. And that's what you're doing in this section. You're taking these big expressions and lightening them up. I can't say it anymore. Lightening them up, making them way less. What do I mean by that? Let's go over here. 2x squared divided by 6x to the 5th. Okay, now 2 over, pretend you don't see this. These are all factors right here. These are all factors. They're all involved in multiplication. Okay, so when you have factors, you can cancel out factors. So in other words, pretend you don't see the x's. 2 over 6. What can you do to that? Well, I can divide top and bottom by 2. That gives me 1, and this gives me 3. Just try to keep track of what you cross out. Now, for every x you have up top, you're going to cancel out an x on the bottom. It looks to me like you're bottom heavy on x's in this expression. You're bottom heavy, and what that means is you've got 5 x's on the bottom, 2 up top, but you know what you can do? Every x that you have up top, 2 of them, cancels out 2 of these, leaves you with 3 on the bottom. So let's clean this up a little bit. Okay, everything up top, when we cancel everything, there's your 1. The top has a 1. 3x cubed. And that's the same expression as this mess right here. This is mathematically the same as this. So mathematicians like to look at this because it's lighter. So come over here, let's put that in there, make a fraction. Put the number 1 up top. And then on the bottom, you're going to type in 3x. And there, we're going to put a little exponent of 3. Let's check our answer. And we're doing some good work. Nice work. Very good. Okay. So that's what you're going to do for the first few problems. Let me see what the next ones are. Let's do this one. Let's do this one. See, 4 and 5 are basically the same thing. This negative might throw you for a loop. So let me see if I can use the same canvas here. Negative 3 t to the 9th s to the 4th divided by t to the 5th s. Okay, so let's take a look. In terms of numbers, you can't do anything with the number. 3 is what it is. There's no number on the bottom that can cancel it. And that negative shouldn't throw you. Just the answer is going to end up being negative. That's all that is. That's all that means. But I'm looking at this. I got t's on top and bottom. These are all factors. I got t's on the top, t's on the bottom. And it looks like you got more t's up top than you do on the bottom. So you're top heavy on t's. So I got 5 t's here. These 5 t's can cancel out 5 of these t's, leaves you with 4 t's. That's t to the 4th. Same thing with the s's. S's are the common base. You can only cancel out common bases. Looks like this s can cancel out one of these, leaves you with 3. So when you cancel everything out, leaves you with 1. What I got up top here is negative 3 t to the 4th. I'm just cleaning it up. S cubed. Okay, now this is not what you're going to enter because you're dividing by 1. When you're dividing by 1, that's silly. It's just enter the top. That's the answer right there. So I'm going to put in just the top because dividing by 1 means nothing really. T to the 4th power. And I'm going to go down to say s to the cube. And that should be a green box. Good job. Fantastic. Okay, now a lot of this stuff you've done in Algebra 1. I know you did that. If you took Algebra here at Stick, that was Chapter 4. Now it starts to get somewhat interesting now. File, let's close this up. File, don't save. File, new. Okay, start a new box here. Let me do this. 4r squared. So the variables all are 4r divided by 20r squared plus 16r. Okay. Now, before you start going and thinking about canceling out the r's and the r squares, that's not math. That isn't math. Okay? That might be math on Mars, but not on Earth here. Okay? If I can just blindly say r squared cancels out, r's cancel out, that's silly. Because let me show you with numbers. If it's not true with numbers, it's not true with variables. So you see 3 plus 6. Oh, I see a couple of 3's. I'm going to cancel them. Leaves you with the answer 6. Right? No, absolutely not. That's wrong. That's wrong. Okay? Because 3 plus 6 in the original problem is 9. That gets divided by 3. That gives you 3. And that's the correct answer with numbers. So if it's not true with numbers, the technique of crossing things out isn't going to work with variables. So what do? Why doesn't it work? It doesn't work because pluses and minuses, which is not what we saw in the previous problems I did. There was no pluses and minuses when we were crossing out s's and t's. Okay? Now we got pluses and pluses and minuses make those bundles. I've always been calling them bundles, and you cannot go inside the bundle and pick out the stuff that you want to get rid of. You either get rid of the entire bundle or nothing at all. So that's one unit in itself, and that's one unit in itself. What you need to do this problem is to break up those bundles into factors. You can only cancel factors, things that are involved in multiplication. So basically what you're going to be doing for these problems in Chapter 7 is double the work that you did in Chapter 6. Like, just take this problem over here. What can we do? I can pull out a 4 and I can pull out an r. Pull out a 4 and an r, and then what's left over. Now, if what's left over would be I pulled out the 4, I divided by 4, I pulled out one r from r squared, leaves you with an r, plus I pulled out everything, 4nr, leaves you with 1. See? Now if I multiply back, I'm sure you'll get this. See, I've got now 3 factors, 4r in the bundle r plus 1. That's a candidate for cancelization. Okay, let's do the same thing down here. They both have r's, so I'm going to pull out an r. I'm going to pull out a 4 too, because 4 goes into 20 and 16. And when 4 goes into 25 times, leaves you with an r here, plus 4 goes into 16 4 times. I already pulled out the r. There you go. All right. Now, you can only cancel factors. I can cancel out the 4s, I can cancel out the r's, and I cannot do anything else. I cannot do anything else. So what's left over is going to be the answer for this problem. Okay, so let me make a fraction. You don't need these parentheses. You could put them in, it'll take it, but you don't need those parentheses because that bundle isn't being multiplied by anything, so you can leave it alone. And 5r plus 4. Okay, let's make sure let's go for it. Don't overthink the problem. Right there. There you go. A third of this homework is done. Okay, a third of it is done. Let's try this one. Okay, we'll do that one. Let me do a fresh sheet of paper, however. Don't save it. Let's come over here and say new. Now again, with this Algebra 2 course, if you're not factoring, you're doing something wrong. Okay? So, let's see. 9s divided by 25r minus 15s. Okay, that's it. Now remember, that's a bundle, and that's a bundle, and you cannot go inside the bundles and pick things out. Can't cross them out, can't touch the bundles. You got to rip the bundles apart. That's all you can do. Rip them apart by factoring. I got r's and s's, so I can't pull out any variables, but I can pull out a 3. Okay, so I factored, that's 5r minus 3s. Okay, now what do we do here? This is the best we can do is 5. I'm going to pull out a 5. 5 goes into 25 5 times, leaves the r, minus 3s. Okay, we factored. Okay, what do we do? What do we do? These are all factors which are good, but you know what? This bundle and this bundle are the same. I can cancel the bundles out entirely. See, with bundles, you either cancel them all out or not at all. What's left over is 3/5. So that big mess that I showed you before, this right here, is 3/5. Now, what would you rather look at, this or this? I think the 3/5 is cleaner and nicer. And that's the whole idea behind doing these problems. Let's check that answer. Well done. Super duper. Okay, let's see this guy. I think I could sneak this in. 6t minus 18 divided by t squared minus 9. Well, right off the bat, just to refresh our memories, this is a bundle and that's a bundle. You can't touch those bundles, what's inside. What you can do is rip the bundles apart by doing the stuff that we did in chapter 6. Well, here I can pull out a 6. That leaves me with a t minus 3. This is a difference of 2 squares, which you shouldn't have to take any effort in factoring. That's a difference of 2 squares. See, that t squared is squaring the t, so you write it twice. That 9 is really 3 doubled up, 3 times 3, one's plus and one's minus. Now, once you got the factors, the fun stuff occurs when you start canceling top bundles, top and bottom. I can get rid of this and this. Those are exactly the same. What's left over is your answer. So it looks like I got, for this answer, a 6 up top, that survived, and a t plus 3. No need for the parentheses. You could put the parentheses. Here I had the parentheses, but those parentheses implied that I was multiplying that bundle by something else. But if that something else got canceled out, don't need the parentheses. Let's see if that's right. Good. Okay. Now I'm going to show you this. There's a little trick to this problem right here. Don't save it. Let's start. File, new. Okay. And let's come over here and write down 1 minus y, and that's a bundle, divided by y minus 1, and that's a bundle. Now, this problem here is strange because in itself I cannot cancel those bundles. Those bundles aren't exactly the same as one another. They're not exactly the same. So I can't cross those out. Don't even think of crossing out the y's, because those y's are inside bundles and you can't touch what's inside a bundle. Again, you can either cancel the whole bundle or nothing at all. And right now I could say nothing at all. But these two things are related to one another. These two things are related to one another. And I can show you the relationship. Okay? This factor here, this bundle looks good to me. You know why it looks good to me? Because the variable's in front. I'm just used to having my variables in front. That's the only reason. This doesn't look good to me because the number's in front. But you know what I'm going to do? I'm going to factor out a minus 1. Just pull out a minus 1. What does that mean when you pull out a minus 1? What that means is every term inside the bundle gets divided by minus 1. So if I divide minus 1 into minus y, pretend I divide by minus y, I get a plain y. Divide minus 1 into 1, minus 1. Okay, so do you see why I'm sort of happy with this problem? Because this bundle and this bundle are exactly the same. And by the way, you could tell that this is the correct answer. Look backwards. This is minus y plus 1 if I multiply through. Minus y plus 1, and it doesn't matter the order. This is exactly the same as minus y plus 1. Okay, just move things around. Okay, that's exactly the same. But let's go back here why I'm so happy. This y minus 1 and y minus 1 bundle cancels, leaves you with a minus 1 divided by 1, and that is the answer, just minus 1. Now, I don't have to go through and do all this stuff here. Okay, I don't need to do all this stuff. What you can do is, whenever you see a situation where, and my mouse is not moving now. Okay, my mouse is not moving. I'm going to have to look at with my touchpad. Whenever you have the situation where, take a look at the top. You see 1 and negative 1. Those are opposites. Minus y and y are opposites. Opposites are an expression and it's negative. Those are opposites. If every term of the top is the opposite of every term on the bottom, you can immediately cross out those bundles and leave a minus 1 in its place. Okay, so let me show you a different, oh, first off, let's check the answer. Check the answer. Okay, good. Let's go on to another one. And let's stop right here. I'm going to have to recharge my mouse here. I'll come back in a second. Okay, I'm back. My mouse is charged, and so I'm raring to go. I think we can have enough battery power on my mouse to do 8 more problems. So let's go back again. I just want to make sure we understand what this means here. If I give you a problem that looks like this, 5x minus 3 and 3 minus 5x, pretend that's what I give you. And that's a bundle, and that's a bundle. Okay? Now, they're not exactly the same so that I can simply cross them out, but they're related because I look at every term that you see inside a bundle. Here's a 5x term. I see negative 5x on the bottom, the opposite. Okay, I come over here. I see another term, minus 3, always with the sign, minus 3. And I see 3, the opposite, on the bottom. If every term you see can be found on the bottom as an opposite, then the entire bundles are opposites. I can cross them out, but leave a minus 1 in the place of the cross out. That's what I'm talking about for problem number 9, the opposite problem. So I think we're going to see another problem like this a little bit later, and I'll make use of that fact to solve it. But this is not one of them. This is not one of them. So what I'm going to do is close this out and just go ahead and say File, New, and OK. And let's come over here and say, well, let's write the problem down. X squared minus 4, and you know that's a bundle in itself, divided by x plus 2 bundle that's being squared. Right now you cannot touch these bundles. You know that by now. It's the same old story over and over again. What you need to do is factor everything you can factor. Now the top, that's a difference of 2 squares. The thing that's being squared to give you x squared is x. So I put the x down twice. I automatically put a plus and minus, and the thing that's being squared to get a 4 is 2. Yeah, we factored it with no effort. That's a 2. It's an ugly 2, but that's a 2. And down on the bottom here I have x plus 2 squared. Now the thing is, this is already, people get all intimidated by this, but you shouldn't feel that way. This is already factored. It just means you've got 2 x plus 2's on the bottom. You got 2 x plus 2 bundles on the bottom. So I'm going to leave it like that with the exponent. Now, what do we got here? I see a bundle, x plus 2, and 2 of those x plus 2 bundles. I can cross out one of these, cross out this, and what's left over is the answer, x minus 2 over x plus 2. Question, can I cross out those x's? Of course not. I'm being a jerk. Of course not. Trick question, because those are bundles in themselves. You cannot cross out anything that's inside a bundle. So let's see if that's right. And oh, by the way, they're not even opposites. They're not even opposites, because even though you see a minus 2 and 2, those are opposites. Every term has to be an opposite. X and X are the same, so they're not opposites. So what I'm going to do is come over here and type in x minus 2, x plus 2, and check my answer. Very good. And only a few more problems left. Only a few more. Okay, let's go back here. Close this. Don't save that. File, New. Okay. Let's move this over. I'm going to write the problem down. At this point, what you should do is automatically get into factor mode. Everything that you see in Algebra 2 needs to be factored. Whenever you see a p squared in a variable and then a number, where did that come from? Edit, undo. Edit, undo drawing. Edit, undo drawing. Okay. So this is going to be a minus 42. Okay, and that's a bundle in itself too. Got to get into factor mode. Okay, the bottom. I'm going to start with the bottom because we've done a bunch of those. Okay, we got a couple of p's for the p squared. I get a plus and minus because you need to generate a negative 42. And it looks like 7 and 6 might be the answer. 7 and 6, because 7 times 6 is 42. And that would add up to be negative 1 in the middle. That's good. That's good. The top, just pull out a 5. P plus 6. And guess what? This bundle and this bundle goes away. I see a 5 up top and a P minus 7 on the bottom. I'm going to put that in the computer. 5, P minus 7. Check your answer. Fantastic. Fantastic. Okay, let me just do a quick scan of of this. Okay. Okay, I don't want to do this one. I knew it would be. I'm going to do 16 and then I'll go back. Okay, before I go on and waste the mouse energy on this, you know what this answer is? -1, without even factoring. The answer is -1. How did I get that? Okay, I see two terms up top, two terms on the bottom. V squared minus V squared, those are opposites. Minus 2V, 2V, those are opposites. If you find opposites of every term, top and bottom, leave a -1. Cross them out, leave a -1 in its place. And so I would leave a -1 up top divided by 1, which is basically -1. Check your answer. Great job. Okay, so let me go back. And do a couple of problems in between. Okay, now this guy here. Let's do this one. All right. I look at the top. You might get into factor mode right away. Just get into factor mode. What do I mean by factor mode? Well, here's my big division sign. Okay, what I'm going to do is I can tell right away that I'm going to pull out an A. So I'm going to pull out an A. And that gives me an A squared plus 8A plus 15. Again, don't even think about crossing A squares and crossing out A's, because these are bundles. Can't go inside a bundle. The bottom, you might as well factor that while we're at it. You might as well go into factor mode there and say A and A for the A squared on the bottom. We need to come up with two numbers that multiply out to be -50, plus and minus. 10 and 5 would do the job, because 10 and 5 would subtract out to be a -5. So I would say 10 here and a 5 there. Okay, so we did the bottom. Ooh, we still have to do this other. This is also an A squared problem. So you know what? I might have to go one more step. I'm just copying what I already know to be correct on the bottom. A, and then I'm just going to look at this top part, and I'm going to give you the answer to that, because you know 3 times 5 is 15. A plus 3, A plus 5, A plus 5 would be 15, and they would add up to 3. So what do we got going here? Here's what we got going. I see an A plus 5 bundle, cancel out, and the rest can't do much with. Can't touch anything else. So what I would do to enter here is, first let's move this over to the side, is you don't need to multiply this stuff out. Just leave it like this. What I see up top, basically I have a fraction. The bottom is A minus 10, okay, A minus 10. The top is A, leave it alone, parentheses, A plus 3. Leave it like that. Okay, leave it like that. Check your answer, and that's a great job. Super duper job. Well done. I'm hoping you're getting this. You're factoring the top. Now this one I'm going to skip. Okay, I'm sure you'll be the previous one was harder than this. You're going to factor the top, you're going to factor the bottom, and things are going to cancel. I'll leave you with something like that. 14. Okay, let's do 14. 14 is difficult. Well, it's not difficult. It's all the same stuff. Okay, it's really all just the same stuff. Different numbers. They look intimidating. Okay, so what I'm going to do is go into factor mode. See, I see a minus. I see these 16s and 25s. Those are squared terms, and immediately I go into thinking that maybe this is a difference of 2 squares, and it really is. So I'm going to not think about it and say, well, I'm going to say, with a difference of 2 squares, don't move the terms around. Leave it the way it is. The thing that's being squared to get 16 is 4. I write it down twice. The thing that's being squared to get 25d squared is 5d. 5d. One's plus and one's minus. Okay, the bottom. The bottom. The bottom looks scary because I cannot factor out anything. There's no number I can factor out. I got to leave it like that. And remember when we did that section on the perfect squares, the trinomial squares? You might think we can use a magic number, and you could use a magic number for this, but the problem is when I pull away the 25, I'd have to generate 25 times 16, which is a big number, and then I have to ask myself, give me 2 numbers that multiply out to be that big number, add or subtract the minus 40 in the middle. That's too hard. That's too hard. I'm going to look at the first terms and the last terms. They happen to be perfect squares. Let's see what we can do with those. What's being squared to get 25d squared? Well, I'm going to say 5d and 5d. What's being squared to get 16? 4 and 4. And I'm going to assume, let's see, double negatives because we need a positive 16 and a negative in the middle. Okay, so I just took a look at the first term and the last term. Asked myself, what was being squared to get these first terms and last terms? And I finagled the signs. And I believe this is correct because if I do outer and the inner, I would get minus 20, and another minus 20 gives me minus 40 d's. That's good. So we don't need, in this case, you didn't need to use magic number. So that's good. So what cancels? What the heck cancels here? Well, let's see something here. You know what? You know what? I see something here. I see something. Nothing is exactly the same top and bottom. But I do notice a relationship between this and this. 4, negative 4. That's an opposite. Negative 5d, 5d. Those are opposites. I can cancel those. Leave a minus 1 in its place. Okay, leave a minus 1 in its place. Nothing else cancels. Nothing else cancels. So what I'm going to enter, this is minus 1 times this bundle. Okay, so what I'm going to do is say minus 1 times that bundle is the same thing as saying minus bundle 4 plus 5d. Okay, that minus in front of the negative is basically negative 1. Okay, so that's negative 1 times this, and on the bottom is 5d, 5d minus 4, and I'm not going to think about it. I'm just going to go for it. There you go. That's it. Okay, if you overthink this, you're going to overthink yourself into a wrong answer. Just have faith that you're doing this right. Okay. 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 Let me just take a look at this. We did 16, 17, 17, and 18. Okay. You know what? I'm looking at this. 15 is very similar. You see, we're going to pull out a T. Okay. 15 is very similar to 17. So I'm going to go ahead and do 17. You might not see a cube, but the cube basically means you're going to pull out a variable, and that variable will cancel out. But in this case, let's do this problem. Let's do this problem right here because the video's getting kind of long. Don't save. Let's do File, New. If you can do this one, you can do them all. 21x squared plus 20x plus 4 divided by 21x squared minus 8x minus 4. Don't even think about canceling out the 21s. That's a bundle, and that's a bundle. Okay? Looks to me like, you can't use that trick of, simply looking at the first terms and last terms, because 21's not a perfect square. I can't pull anything out from the top. Same thing on the bottom. It looks like I got 2 magic number problems to do. Oh dear. So what I'm going to do is I'm going to go and factor it. I'm going to go ahead and take the 21 away from that x squared, circle it. X squared plus 20. Oh, that's an ugly looking 20. Let me do edit undo. Edit undo. Edit undo. Let's make a better looking 20. X. Okay, but now this number here is 21 times 4, which is 84. All right, now we should be able to factor that. I need 2 numbers that multiply together to give you 84. Multiply together to give you 84. If you can't tell by looking, but they have to add to be 20 in the middle. I showed you this website that I wrote, okay, and I'm going to go here. Let me open up another browser. I have a link to this inside the Blackboard. I have a link somewhere in the Blackboard. You'll see it on the module, but the link to it is bytecodeman.com/special apps. Okay, and there's an app right over here, number factoring. I'm going to punch in the number 84, hit enter. And the thing that you want to look at is the middle term, which is 20. These are the numbers 6 and 14. 6 and 14 would multiply out to be 84. Let's keep that alive. Looks to me like this would be x and x plus 6 plus 14. Wow, okay. What do we do now? Well, what you do now is you make fractions out of those numbers, 20 with the magic number, 21. Simplify the fractions. Divide top and bottom by 3, which is 2/7. Gotta simplify the fractions. And over here, x plus, I think I'm going to divide top and bottom by 7, which is 2/3. And if you still have fractions, that's a 7. You move the denominator in front of the variable, 7x plus 2. And this is 3x plus 2. Okay, now let me move this over here. Okay, now what I'm going to do is the same thing for the bottom one. The bottom one looks like the magic number is still 21. X squared is what we're going to factor, minus 8x minus 84. Okay, 21 times 4 is minus 84. I want 2 numbers that multiply together. Let me get myself ready. X, and it looks like it's plus and minus for the negative 84. Let's go to that website. Okay, punch in 84. Punch in 84. And do you see 8? I see 8 over here. 8. The same number, 6 and 14. 6 and 14. So 6 and 14, if I put 14 over here and 6 over here, I will get negative 8 in the middle. Not done yet, of course, because we're going to make fractions out of these numbers here. And we need to simplify the fractions. Divide top and bottom by 3, which would be 2/7. And this one here, we're going to divide by 7. X is 2/3. And we still have fractions. And if you still have fractions, move the denominators in front of the variables. 7x plus 2, 3x minus 2. Okay, the hard work is done. The fun stuff is this is the top, 7x, rewrite the top as factors. Now take this as the bottom, 7x plus 2. And this is 3x minus 2. Wow, with all this work, the only thing I can cancel is that same bundle, 7x plus 2, 7x plus 2. These are not opposites. These are not opposites. It's not 3 negative 3x. So I'm going to say that's the answer right over here. After all that hard work, I better not get a red box. Okay, I'm going to make a fraction. 3x minus, no, plus 2, 3x minus 2. Check your answer. Uh-oh. That's it. Good. Great, great, great. And the last one. Okay, this looks intense. It looks scary, but the bottom line is it's a double variable problem. Forget the second variable and factor it. Let's see what you get. Let's see what you get. Don't save. File new. New. Okay. Okay, so here we go. I'm going to take a look at the top. I'm going to forget the second variable. I'm going to factor that. That's equal to A and A plus and minus for the negative 18. I'm going to go 6 and 3. That would give me positive 3. But remember, this is true for this problem. The original problem up top had a b squared, so we just tack on that second variable. That's a b, and that's a b. Remember, that's what's going to be on top. Let's look at the bottom now. The bottom. Let's go with the bottom here. I'll put the bottom over here. 2a squared minus 9a. Forget the second variable. Plus 9. I got to use a magic number. Can't pull anything out. So magic number is 2. So what we got to do is factor a squared minus the middle term, which is okay. But 2 times 9 is 18. And this is going to be, what's that going to be? It's going to be a and a, double negatives for the positive 18, 6 and 3. 6 and 3, but again, we forgot the second variable. What you're going to do is put the variable back in at the end with the attached to the numbers, because we want 6b and 3b to generate the 9. Wait a second. Whoa, stop. Let's undo. Everything's cool up to this point. I spoke too quickly. File, edit, undo. Let's undo this. Edit, undo, Control Z. Okay, let's get rid of this. Okay. This is all wrong. That's all wrong, so I need to erase it. Sorry about that. Okay, we erased it. So, our factoring is good. A and A. Okay, double negatives, 6 and 3. Okay, 6 and 3. Problem is I didn't do another step. I got to make fractions out of these numbers with the magic number. Okay. Simplify the fraction. 6 over 2 is 3, so that's pretty simple. A minus 3. 3 halves I can't simplify. So, put the denominator in front of the variable, and we're good to go. Now the problem here is, that's all well and good. That's multiplied. When you multiply this, you get 9, but you want 9b squared, so put down a b here and a b here, tack on that second variable, and you're good to go. So up here, what I'm going to do is transfer this mess, hopefully a lot cleaner. That's a lousy divided by sign. I'm going to say a minus, that's a 3b down there, 3b bundle. And this is going to be 2a minus 3b. And I hope something cancels. You could do all this work and not have anything cancel, in which case you did all that work for nothing. They won't be that mean in this in Algebra 2. There's going to be a treasure at the end of all your work. So here's my treasure. Cancel this guy and this guy. And what's left over is a plus 6b divided by 2a minus 3b. Boy, I hope that's right. I hope that's right. I can't stand failure again. A plus 6b. Make sure you use lowercase letters. Bottom is 2a minus 3b. Check that answer. Thank goodness. Okay, so I think we're done with this section. Give it a try. Give it a chance. Just remember, when you have bundles, you cannot delete inside. You can't cancel out anything inside a bundle. You either cancel the whole thing or not at all. All right. Give that homework a try.